Hello, students. Welcome back to our next day taking lessons on minerals. So, yesterday, if you recall, we left off talking about the properties of minerals and the definition of minerals. And we talked a little bit about the identification of minerals. Well, one of those components of identifying minerals and examining them in greater detail is checking out their hardness. Now, if you remember from yesterday, hardness is a mineral's resistance to scratching. Okay, so we're going to pick it up here today with hardness scales, and we're going to be talking about two hardness scales at the beginning of the period here. And the first one is called Mohs hardness scale, and you'll watch a little video about Mohs hardness scale, and you will discover that Mohs hardness scale is named after Friedrich Mohs, a scientist who developed the scale in 1812. Ooh, 1812. That sounds like a famous date in American history as well. I think there was a war that took place that year. I think it was the War of 1812. In fact, that's the war during which the Star Spangled Banner was written by Francis Scott Key down in, I think, the Baltimore Harbor down there, so, by Fort McHenry. Fort McHenry, yeah. So during that same year, that was a long time ago, during that same year, Friedrich Mohs developed the scale, which is based on 10 minerals. You see, what Mohs did was he utilized his knowledge of mineralogy, the study of minerals, and he knew that some minerals were harder than others. And he developed this system of the softest mineral to the hardest mineral. And he chose 10 different minerals that he felt were common enough that people would be able to obtain them, geologists in particular, in order to base this scale on. So let's begin. Let's begin with Mohs hardness scale with item number one, which is talc. Talc, as we have mentioned before, talc is the softest mineral. You saw it in a video yesterday or a couple days ago regarding talc. Can be pulverized into a powder that is silky smooth. You may have opportunity to feel it this week in the laboratory, creating a powder called talcum powder. But that powder comes from a mineral that is used to make talcum powder, and it is super, super duper soft. And when we say soft in the context of minerals, we're talking about the opposite of hardness. A truly hard mineral, you could not scratch it into a powder like you can talc. You could try all you want, but you're only going to be scratching your fingernail and not the mineral itself. But talc, you can scratch with your fingernail very, very easily. All right, number two. Number two on Mohs hardness scale is gypsum. Now, if you're into construction, like to build things, you might have heard of gypsum board. Gypsum board is otherwise known as sheetrock. Sheetrock. And it's called sheetrock because we use sheets of this rock, which is really a mineral, to build houses with. Chances are your house has gypsum board or sheetrock that form the walls in the inside. Now, hopefully, none of you have ever been angry enough to punch a hole through a wall. If you did, you would expose the gypsum, the second softest mineral on Mohs scale, which is what many of our homes are actually made of. Number three, calcite. Calcite is rather interesting. A number of years ago, there was a cave that was discovered in Mexico. And I want you to look at this picture for a moment because you can see these crystals here. What you may not pick up initially is the fact that there are human beings walking amid these gigantic crystals. The largest crystals in the world were found here in Mexico. And this cave has the perfect conditions to grow outrageously large crystals. Unfortunately, the ideal conditions are heat and humidity. In fact, this cave is so hot and so humid that these poor folks climbing around in this cave can only stay in this cave for about 10 minutes or so before they have to leave. They have special insulated outfits on and breathing apparatus. It's almost like they're astronauts on the surface of Venus or something because it is so hot and humid in here. Without protective gear, they would die. Excuse me, but just the mere suggestion of heat and humidity makes me tired. But calcite, we see calcite crystals in my mineral collection, but they are nowhere near as large as these. Calcite also has some other interesting special properties that you'll discover on lab day. Number 4 is fluorite. Perhaps that sounds familiar to you, fluorite. Does it sound like fluoride? And maybe like the stuff that's in toothpaste or tooth rinse, mouth rinse? Well, it is because fluoride is obtained from the mineral fluorite. And the Egyptians, thousands of years ago, discovered that fluorite, when consumed, it actually strengthens your teeth. Your teeth are made of minerals, and fluorite is a mineral that helps to strengthen your teeth. So there's a mineral that is very beneficial to us. Now, if you live in an area where you have well water and not city water, like many of you might live in that are listening to this video, in younger grades, someone during health class or phys ed class or homeroom period, you might actually have to rinse, swish, and spit little cups of purple fluid. That's a fluoride treatment. Maybe some of you do it at your dentist on a regular basis anyway. You know, it's not a bad idea to be treated with fluoride. Number 5, this talk about rinsing mouths out is giving me an appetite. Ha ha, but-um-bum. Apatite is the next mineral, although you really wouldn't want to be eating apatite and it wouldn't do much for your appetite. Number 6 is feldspar, one of the most common minerals on planet Earth, followed by quartz, which is the most common mineral on Earth. In fact, sandy beaches. I love to go to sandy beaches and boogie board in the water and swim in the ocean and just listen to the waves crash on the shore, turning rocks into sand. And sand is made primarily of quartz. Silicon dioxide, the most common mineral on planet Earth. Topaz is number 8. Number 9 is corundum, followed by diamonds. Now, as we look at this completed list of Mohs hardness scale, I want you to remember something. This is a hardness scale. If you had a sample of talc, talc could be scratched by gypsum. Gypsum could be scratched by calcite, but gypsum could not be scratched by talc. Calcite can be scratched by fluorite, which can be scratched by apatite. Apatite having a number having a value of number 5 can be scratched by everything 6 and above, but cannot be scratched by anything below 5. Number 6, feldspar, can be scratched by quartz, topaz, corundum, and diamond, but cannot be scratched by apatite, fluorite, calcite, gypsum, or talc. So with that in mind, you can probably guess that quartz, having a hardness of 7, can be scratched by anything above, but by nothing below. Topaz. Topaz is a gemstone. Some people have topaz rings or earrings or pendants because topaz is one of the 3 hardest minerals on planet Earth. Corundum is even harder than that, and diamonds. By the way, rubies are a type of corundum. You've probably heard of rubies before. Rubies are a type of corundum. And diamonds, of course, diamonds are the hardest mineral on Mohs scale, and they are the hardest mineral on Earth. If you ever have to go to a dentist because you didn't consume enough fluorite when you were younger and your teeth were developing, in order to drill through your teeth, which are really hard themselves, they use a diamond drill. Now, I know some dentists will use laser beams to shoot holes into your teeth, but if they don't, they'll use a diamond bit drill because your teeth are so, or should be, so hard. All right, now there's a little memory aid here that can help you remember the correct order of the minerals on Mohs hardness scale. And so what do we have here? Gosh, we've got 2 cats and we've got a fly, and what's going on here? Well, 2 giant cats are following a fly quietly to catch dinner. Now, flies will probably be attracted by dead fish, so the cats are probably following the fly to a dinner of dead fish. But 2 giant cats follow a fly quietly to catch dinner. If you look at the first letter of each word, you can go from talc, the smallest, all the way up to diamond, the hardest. Now, I'll give you some bonus points if you can come up with a better memory aid, which I'm sure you can, a better one than this to remember the correct order of the minerals in Mohs hardness scale. But here's the deal. I mean, those minerals, for an average Joe Schmo like me, I may not have access to all of those minerals. If I'm out in the field, on a geology trip, and I'm trying to test the hardness of certain minerals. So I may not need or use Mohs hardness scale, but there are some common items that I could use on a different scale called the field hardness scale. You see, the field hardness scale uses more common materials that you probably have at your disposal. Certainly, if you're a geologist, you have these that you can easily carry in your pocket in order to test the hardness of minerals. You see, I have actually a kit here of Mohs hardness scale, and I have all of the minerals here for Mohs hardness scale. These would be kind of tough to fit in your pocket going out on a field trip. So again, there are some more common materials for field hardness scale, beginning with something that's already attached to you, your fingernail. Your fingernail, if you are a healthy individual, your fingernail actually has a hardness of about 2.5 on Mohs hardness scale. So if you can scratch a mineral, you can say that that mineral is softer than 2.5 on Mohs hardness scale just by using your fingernail. If a mineral scratches your fingernail, well, you can say it's harder than 2.5, which is still pretty soft on Mohs hardness scale. The next one is a copper penny. a copper penny. I'm talking about a real copper penny, one from before 1982. Copper pennies are made of, as you could probably guess, copper. And copper pennies, copper is on Mohs hardness scale with a value of about 3. So if you can scratch a copper penny with a mineral, then its hardness is greater than 3. And a penny is something that can easily fit into your pocket. Now, we're not going to be working with knives per se, but most geologists will have like a pocket knife in their pockets. But we're going to be using a nail, which is about the same, and a steel nail or a steel knife has a hardness of about 5 on Mohs scale. So if you've got a nail, which you will be using in the lab on Friday, and if a mineral can scratch a nail, then that mineral has a hardness of greater than 5. If the nail can scratch the mineral, well, you can say the mineral has a hardness of less than 5. Brings us to the next one, a little piece of glass. Now, you don't want to be carrying broken glass in your pocket. However, as you will see in the lab on Thursday, we're going to be using hardness glass, which has smooth edges to it. But a small piece of glass has a hardness of about 6. And so, again, if you have a mineral that you think is harder than a value of 6, see if you can scratch a glass plate with it. If you can, then that mineral is pretty hard. They say that a simple test for a real diamond ring is to take that diamond ring and scratch glass with it. Real diamonds are much harder than glass, hardness of 6, and so a real diamond will scratch glass. Now, I wouldn't suggest doing that if you're not sure it's a real diamond, because if it's a fake diamond like cubic zirconium or a even cheaper imitation, like a Cape May diamond, which is actually quartz. If you try and scratch glass with a quartz diamond, well, it's going to scratch and destroy the quartz. So be careful. But a real diamond will scratch glass without a problem. And that brings us up to a steel file. A steel file, and we'll be using small steel files. People years ago used to use steel nail files all the time. Those steel nail files would be great. Sometimes they're even included in like a Swiss Army knife or nail clippers. A steel file is even harder than glass, and a steel file has a hardness of about 7. So again, if you've got a mineral that can scratch a steel file, you're talking you've got a really hard mineral like corundum or a diamond. Really, really hard. And so those are the basic items that you would have in a field hardness kit, a lot cheaper and easier to come by than Mohs hardness kit. But you get the idea. All right, we're going to finish off here today with the 6 basic crystal shapes. I'm going to review them, and then you're going to watch a little video clip on them. I'm not going to necessarily ask you to memorize all of their names, but I do want you to be familiar with them and certainly familiar with the more basic, more common ones. So let's begin with the simplest crystal shape, and that is a cubic crystal shape. I've already shown you some examples of crystal cubic shape, a cubic crystal shape like pyrite. Pyrite is an example of a mineral with a cubic crystal shape, and in the mineral collection that I have, there's a great example of that. All right, the next one is called tetragonal. Tetragonal. Tetragonal, tetra is a prefix that means 4, and a tetragonal is a 4-sided kind of a pyramid-like shape on both ends, but it's got 4 sides. So tetra means 4. Tetragonal is a 4-sided crystal. The next one is called an orthorhombic crystal shape. And we've got some minerals in the collection that you can check out that do have an orthorhombic shape to them. And you may recall from math class what a rhombus is. I'll leave that to math class, but orthorhombic. Next one is hexagonal. Hexagonal is a common crystal shape. Some of the minerals that have these crystal shapes include quartz. And if you look at the beautiful specimens of quartz crystals in the mineral collection, you will see that they do in fact have a six-sided crystal shape, which is called hexagonal. In fact, the prefix hex means six. So six, hexagonal, six-sided crystal shape. Monoclinic. Mono means one. Clinic means flat, basically. So a monoclinic is a very thin, flat-shaped mineral. A couple days ago, you saw the video with some examples of monoclinic crystals, but that's basically the shape of them. Triclinic, very similar, but triclinic, as you can imagine, have one, two, three sides to the clinic portion of the mineral. And those are the six basic crystal shapes that we will be exploring and utilizing this week. You can certainly refer to your book during the lab activity to refresh your memory about the names of these, because some of them will be beneficial in identifying minerals. And I just want to add I want to remind you, I should say, that these crystal shapes are based on the repeating atomic pattern that exists within the molecular structure of a particular mineral, which is determined by the definite chemical composition. Think about those characteristics and properties from yesterday, and you'll see how it all ties together. Now, tomorrow you are going to have 10 unknown minerals here. And your objective tomorrow is going to be to try to identify the 10 unknown minerals. Now, I'm going to try and save you some time by giving you some hints along the way. So for each of the minerals, I'd like you to start with the hint. But utilizing that hint, you're then going to try and find some other characteristics, including the luster, the color, the streak, heft, crystal shape, breakage, hardness, any special characteristics. Get as many of those characteristics as you can, but the one that I'm really drawing your attention to is the column under hint. That will really help you identify the mineral based on the information that I have in your book. I'm giving you a chart in your book with all of the properties of the mineral, including some special properties for you to pay attention to. And in the first column, I'm giving you the identity of that mineral. So I'm really curious how many of you, who will get the most correct with tomorrow's lab activity. I'll be giving all of you some additional guidance with tomorrow's lab activity. But I want to give you as much time as possible with tomorrow's lab to see which group can identify the greatest number, because the groups that do will earn some bonus points for the week. So study this chart for tomorrow so that you can be more familiar with it. The more familiar you are with the various characteristics of these minerals, the better your chances of identifying a larger number of them correctly and more quickly. So until tomorrow, I'm going to say Bye-bye.